So when we say gut instinct, it's kind of interesting that very often the first response you have to a severe stress is a icky feeling in your tummy, right? It's, you know, something's not quite right, and that not quite right feeling is sometimes perceived in your gut before it's even fully perceived by your nervous system. So there's actually a ton of serotonin in your gut. Much more serotonin in your gut than there is in your brain, but it does interesting things in both places.
And now we come to the next session, which I'm personally really excited about, because we were talking about the health of the nation earlier. This is about something even more intimate and germane, which is our own health. I again want to reel out just a few statistics to drive home how urgent this conversation is. You know, post-COVID, the world over, mental health statistics went through the roof. But even without that spike, you know, which had a kind of locus and a local driver, globally, mental health statistics are very deeply worrying. And stress has become one of the, you know, perhaps one of the topmost drivers, not just of ill health, but of death. The numbers in India are so deeply troubling. You know, again, statistics vary, and we were seeing earlier about how you can interpret statistics, but I'll still reel them out. 1 out of 4 teenagers in the age group between 15 to 18 suffer from mental depression or somewhere on the spectrum of anxiety, or even those who want to commit suicide. Adult figures are equally worrying, and I'm loath to say it because there's such a swing, but it's enough to show that it's very worrying. It's between 37 to 57% of India suffer from, again, some sort of, you know, on that spectrum with different degrees of severity, suffer from either stress, anxiety, depression, bipolar, other forms of schizophrenia, mental health diseases. And here's one last statistic, that 30% of those across the world who suffer from mental health diseases are immune to all the drugs that are currently available, which makes our next speaker really catalytic. Vidita Vaidya is an Infosys award-winning neuroscientist. She teaches and works at the Tata Institute of Fundamental Research. She and her team have been looking at the canvas of stress in the brain, the circuits of stress, and the use of psychedelics as a possible wonder therapy. This is a very complex zone, and right now, they've made a global breakthrough in isolating a circuit of stress that particularly responds to psychedelics, and they've been able to isolate that in rodents as a potential breakthrough, global breakthrough in how to cure stress and anxiety symptoms that is otherwise immune to other drugs. So to speak of that, to speak of our brain, that great mysterious universe, serotonin, this miracle you know, molecule that resides in all of us and is 3 billion years old, and this very unexplored yet ancient arena of psychedelics. Ladies and gentlemen, please welcome Vidita Vaidya. Vidita, congratulations. You know, the news has only just come out, and you have scientific journals across the world covering your team and your breakthrough. So thank you. This is the first time she's speaking publicly about it, so it's really exciting. Vidita, first, before we dive into the breakthrough that your team has made, I just want to familiarize the audience with this whole landscape in our brain, you know? So let's just first start with stress. All of us feel it. Anxiety is like a common affliction. So what really happens in our brain? Why has it become so prevalent, you know?
Okay, let me just first, thanks Shoma for having me here first and foremost. That was an amazing session right before this. I think the maximum amount of activity we're going to have now is neuronal activity. I don't think we're going to have much else than that. So just coming back to the question you had, stress has been a part of, you know, any organism's environment ever since we've been on this planet. And you can imagine that these systems were essential when we had a predator-prey relationship in the world where we could potentially be prey or we were predators. For example, if you didn't want to be eaten by something, you needed to make sure that you could mobilize glucose to your muscles, move really fast, escape, usually not stay to fight, but run away as fast as you can. So our systems, and all mammalian systems, in fact non-mammals as well, but mammalian systems are beautifully evolutionarily designed to have a fantastic fight or flight response, and that is your stress response. So all of us have it, rats, mice, humans, our non-human primates. Essentially, anytime you face a stress, you sense it through your body or your brain, and then you activate your hypothalamus, which produces one hormone, CRF, which then goes down to your pituitary, which secretes ACTH, which then goes to your adrenal glands, and you secrete cortisol. And that hormone is the canonical stress hormone, right? So every one of us produces it when we are under stress. And the good thing about it is you produce it, you have a quick peak, and then you come right back to normal because you want to utilize this hormone fast to do whatever you want to do quickly, because survival is a quick decision. I mean, you need to shut down your digestion. You want to shut down reproductive pathways. You want to focus all your glucose to your muscles, etc. This was a system that was designed when we were wandering around, whatever, prairies of something, and where we had animals chasing us, etc. But the evolution doesn't move on the time scales that cultural changes happen in our worlds and societies. Now we activate it when our boss hates us or we hate our boss. Now you activate it when you perhaps, you want a follower to like something you've done, etc., and that doesn't happen. The same pathway is being used today for, more often than not, chronic social reasons, so social stressors. And it comes up, and then it doesn't come back to baseline really well. And if you do that sustainedly, then these hormones, while they are very powerful and essential for your survival, in the long term, if you bathe your body and brain with cortisol, that's bad news. And that's what we're doing. What our stress is has changed.
So, why is that quick, Crystal? Just to understand this whole stress phenomenon a little bit more, why, you said earlier it would peak and it would go away. Why is that? Yes, as you said, the triggers have become, so facile almost. It's no longer a tiger trying to eat us, but a boss, or whether you've got enough likes on social media, etc. But then why is at least the spike not going and then coming down? Why has it become so chronic in our societies?
Okay, so the reason it comes back so quickly back to baseline is it's a beautifully feedback controlled system. So your body senses that you've released cortisol. That cortisol goes everywhere. It also goes back to your brain, and it goes back to a part of the brain called the hippocampus, which is essential for learning and memory. And then you use that structure to shut down the pathway. That's why it's so beautifully tuned to being controlled. But under chronic stress, the receptor through which it works in the hippocampus, the expression of that goes haywire. More often than not, it's lowered. You can't kick in a feedback regulation. You can't stop the pathway. And so you end up with a much longer and slower return back to baseline. And that's something that one has seen now over and over again in animal models. Of course, it's seen in non-human primates. It's also seen in humans. And that's what causes the pathway to not return quickly back to baseline. It's not that it is incapable of it. It's just that your body's anticipating that the stress is probably going to be longer or not going to. So you're adjusting your feedback regulation of it. Yeah.
Right. So, before we go into psychedelics, which is and now it's had an upsurge, but like you've said, and our film showed that psychedelics actually has been around for 10,000 years, and all our, particularly India, Latin America, elsewhere, have had a huge reverence for that. But there's so much of debate around it now. So I'll come to that. Before that, just in pursuit of the human body, would you share with the audience what serotonin is, why it's so important in your study and in relationship to stress, And what makes it such a miracle molecule?
So it's an evolutionarily really old molecule. It's 3 billion years old, which is the earliest stages of multicellular cells evolving on this planet. We weren't around. There were no organisms that even had anything that looked like a neuron around at that time. But this was, it co-evolved in a sense in plants, to do a lot of stress handling in plants. So it does a great job of helping plants to cope with stress. I think we just in evolution co-opted it, so animal evolution co-opted it and utilized it as one of many other stress modulated molecules. It's a critical regulator of many of our stress responses. It allows you to adapt rapidly. So it's one of the vital molecules in that sense. It's not the only one.
And so I'd like to share that Vidita used a wonderful phrase that stuck in my brain. It's like the petrol station of your entire body. It fuels everything that we do. But where is it located? Is it like a localized thing?
So there's a part of your brain which produces serotonin, but the neurons sit in your brainstem, but they project everywhere, all across your brain, down to your spinal column. But actually, there's way more serotonin in your gut than there is in your brain. So when we say gut instinct, it's kind of interesting that very often the first response you have to a severe stress is a icky feeling in your tummy. Right? It's something's not quite right, and that not quite right feeling is sometimes perceived in your gut before it's even fully perceived by your nervous system. So there's actually a ton of serotonin in your gut. Much more serotonin in your gut than there is in your brain, but it does interesting things in both places.
Right. Okay, so now let's bring in the third actor on stage, which is the psychedelics. And particularly in America, there's been an upsurge of investigation into LSD, ayahuasca, mescaline. Will you tell the audience again that what is special about psychedelics in relation to stress? What is this long history around psychedelics, and what makes them, again, such special, they're not chemicals, special molecules?
So I think as long as we've had human beings on this planet, we have taken psychoactive substances of some kind or the other, right? The most common one is coffee or tea. It's a potent psychoactive substance. Caffeine has very interesting effects on your brain. So when we think about psychoactive substances, there are psychoactive substances that are legally allowed, and then there are ones that we have, for whatever reason, legislated and kept behind usage. But that's relatively recent. In fact, if you think about the history of human beings utilizing psychoactive drugs, it goes back to the very earliest times. The oldest data, something like 9,000 years ago, from cave paintings where you see medicine men with mushrooms in their hands, suggesting that shamans probably did use mushrooms, potentially as part of their healing ceremonies. There's actually this huge debate about whether cave art, and in cave art, sometimes you see not just the domesticated animals, but you also see fantastical images of a single-eyed human being, where people have suggested that it was alien invasions that people were perceiving. It's more likely that they were consuming psychedelics and having full-fledged altered perceptions, which they then painted out on the cave art. And so there's this whole idea of whether the evolution of art as we understand it from cave art actually came along with the consumption of these substances. So these substances have been used in multiple civilizations world over, largely, of course, in Central and South America. The Incas used it extensively, and mescaline, which is from the peyote cactus, was used. So the first known ban is associated with the Spanish invasion. 1620 is the first known ban, where there was this view that this was a violent attack on the church because this was heresy, and it suggested that there were gods floating around everywhere other than the one real God and the one real church. So it's interesting to see that history. But it continues for a very long time until it shows up in Western cultures where LSD was first synthesized by fluke.
By Alfred Hoffman.
Yeah, completely by fluke, right? He was trying to make an antibiotic, which is fungus-derived. In the process of that, instead of making an antibiotic, he ended up making something else, which he thought was completely useless as an antibiotic, left it on the shelf, didn't do anything with it, until one day he decided he was going to take a little bit of a dose. And he thought he was taking a very low dose. He was actually taking a very high dose. And he drove a bicycle back home and asked someone to come with him to watch him. And he thought he was dying because all sense of self started dissolving. And so he had this whole major trip, which he detailed in extensive detail. But that was when LSD was introduced to the world, in a sense. And then there were many, I mean, there was the period of the 50s and 60s that followed after that. There was still ongoing work on these molecules, but then in the 60s, you know exactly what happened. And it's actually just interesting to think about, because in that period of time, that's also a period that is post another mushroom, the mushroom cloud, which is associated with atomic war. And when you think about banning something, you have the choice of banning the mushrooms which were used for thousands of years, or you have the choice of banning something that can produce that sort of death and harm, but you pick the mushroom to ban, which is the ayahuasca and the psychedelics, but not the... So it's interesting. I think these molecules are very potent, and they often are the greatest challenge to two of the ideas that allow us the justification of violence. And the two ideas that allow us the justification of violence are nationhood and religion. These are the two that have sanctioned violence as ideas for posterity for mankind, right? And what happens under the influence of the psychedelics is that you do not see a segregation or separation between yourself and the universe, perhaps, and certainly between yourself and another human being. And that then the artificial notion of nationhood or the artificial notion of a separation becomes far less meaningful. But they also have these therapeutic effects on anxiety and depression. Right. Sorry, long-winded answer.
No, fascinating. And I'm going to bring you back to your own work and this breakthrough, but I just wanted to share with the audience again just the nature of these psychedelics, you know. So 2 questions around that. And, you know, I don't know how, I mean, I don't think anyone here has tried it or may have, but it also really opens doors of perception, and there's a great linkage between spirituality and psychedelics, you know, that people who take it come back speaking of experiences which is very similar to the Vedantic idea of actually ego dissolution, or feeling that you're one with a Brahman, unbroken love, a sense of identification with trees, with nature. So help us understand that, like why does that happen, and how then we'll come back to why it's related to disease.
I mean, I think I'm going to answer it using the answer that Swami Sarvapriyananda gave when you did the conversation with him at Synapse, because I thought it was such a profoundly good answer. And I went back and then I realized that that comes from Swami Vivekananda's writings, where he asked that if you can access altered states of consciousness and altered perception, which perhaps may give you a connection with something much larger than you, a universe and an idea that's much bigger than you, if you can just do it by taking this drug, what is the value of the approach that involves meditation or practices that have been used by a variety of practitioners world over? And the answer was, yes, sure, you access these states, but let's say you're a fool and you use the drug to access the state. While you're under the influence of the drug, you do indeed access that state, but when you come back, you're still the fool. And alternatively, well, that's not necessarily always true, but let's say let's say we buy that. The alternative is you do the work, okay? So you do the meditative work on your brain circuits that allow you to access these states. When you come back, you're still coming back. You're not staying in that state continuously, but you've built character in the process. And maybe the exercise about building character is the real, actual important thing than necessarily staying in that plain sort of continuously. So I really like that answer. I thought it was a very profound answer. But it is true that these molecules do allow you to access states that people also access in other ways. However, that's presuming that it is a good trip. There are plenty of examples of horrendously bad trips where people have felt extremely uncomfortable and had to be reassured that this will end, because at some point the drug runs out of steam and it's metabolized by your body and it's gone. So it's not a given that it's necessarily only going to give you that. There's a huge influence of setting, dose, drug. These are very, very potent molecules, and certainly not something to potentially be played with without the due respect that they should command, because they really can change brain circuits quite potently.
So again, like I said, I'll come back to the core thing that we are discussing, which is stress relief and why the use of psychedelics is being discussed. But before that, again, to understand the brain and what happens. So, when we say that there's ego dissolution when you have psychedelics or when you meditate, the whole idea is to let your ego self die down and connect with a higher dimension. What happens? Like, what is the ego self? What is the part of the brain that shuts down? And when you have these psychedelics, are you just accessing a different part of your brain, or are you accessing a genuine another dimension?
That question I won't be able to answer, but I'll start with the first part because we don't have an answer to what you're asking. But I'll start with the first part. So let's say in this audience, right, people are listening to me. Let's hope some of them are paying attention. But there might be some who are thinking, I left this. I wonder if I shut the door on this. I wonder what is my plan tomorrow morning. They're in a ruminative state. When you're not necessarily fully concentrating on something, your brain is still doing stuff in the background with background noise going on. That's your ruminative default mode network. And it's usually highly self-referential. We look at the world through a very self-referential lens. Everything is with reference to how it matters to us. And so the brain is doing its job back there with the default mode network. Under the influence of psychedelics, you get flipped out of the default mode network because of the way these molecules work on specific receptors, taking you to an altered network functioning, which involves multiple other networks kicking in. That sometimes breaks ruminative, self-referential thought. And so you can see the world through a different lens if you are not solitarily the center of the world. Almost all psychiatric disorders that fall into the category of depression, anxiety are ruminative disorders. They arise as a consequence of a disconnect of what you feel with reference to yourself and your world as it is. The ability to flip you out of that by using, in this case, a drug. I mean, there are other ways to flip you out of that as well. So cognitive behavior therapy, there are many other ways that work, but this ability to just shift you straight out is one of the things that psychedelics do, and that's why they're so powerful. Why they allow you to, have these phenomenal altered perceptions is because they hit. So all our information that's conveyed to our higher cortices comes from peripheral sense organs, right? So let's say I'm seeing you. So I have information in my retina that goes to my thalamus, the lateral geniculate nucleus goes to my visual cortex. That's how I recreate an image of you. Under the influence of a psychedelic, without information going from the retina or the thalamus, I can straight out hit receptors in my visual cortex that can make me see things that perhaps don't exist, right? So what is the other condition that gives you that? The other condition that gives you that is schizophrenia, right? Where you could have altered perceptual states. So that's why these drugs are psychotomimetic. They mimic what happens even in a schizophrenia-like state. So I just want people to know that while they are very potent molecules, there are these other sides to them that are a little worrying as well. And that's why they are so important for us to understand effectively if we want to harness them. The question you asked about how do they allow you to access universes that perhaps we have no clue about, I don't think we have a good answer for it at all.
But I'm now going to come back to stress and anxiety and the medicinal qualities of these. But once before when we were chatting, you said that neurological systems do have a capacity to link with things outside of yourself. What does that mean? And would you share that with the audience?
Our brains respond not just to what's going on in our nervous system, they respond to what's going on in someone else's nervous system, which is how communication happens. The most obvious one being the spoken word. We just talked about it, but there's a lot more than the spoken word. There's a lot of other information I'm gathering. I'm looking at your face, I'm looking at your emotional rest states because your face is representing what you might be feeling. So there's a lot of information that we're picking up. We have neurons in our brain called mirror neurons, which was a beautiful discovery that was made by Rizzolatti many decades ago, where it was done with monkeys. And the experiment that he actually thought was a failed experiment and ended up discovering it was made a major discovery. So there are neurons in the brain that respond when the monkey picks up an object. Okay? And every time he would do the experiment, he would set something in front of the monkey, and he was putting the the object in front of the monkey, and these neurons were firing out of whack. Not when the monkey was doing anything, but when he was doing it. And that's when, over time, he realized, oops, the monkey is watching me do this motor action of moving this object, and its brain is responding when, as if it was itself doing that imitative action. Now, that was the first discovery of mirror neurons, which indicate that you have neurons firing in your brain, not just to your own actions, but to someone else's actions, which are then mirroring activity. That may not just be true of motor control, that may also be for emotional states. There's enough reason to believe that there are neurons that respond actively to the state of mind of another individual around you. And that perhaps is the underlying basis of empathy, our ability to feel another's pain, to sense or attribute emotions to them, because we know what it would feel like if we were in that situation, right? So this was one of those discoveries. So yes, we do respond to a lot of things that are not necessarily just our body, but happening to someone around us.
Right.
Yeah.
So I'm going to come back to the spiritual and consciousness dimension of psychedelics, but to come back to your work, would you share with the audience, what did you first win the Infosys Award for? What was the breakthrough there? And then we'll come to this most recent breakthrough, and how do psychedelics impact stress?
So that was for a purely fluke, serendipitous discovery. It's the kind of thing where you're just having fun in the lab and you discovered something you had no real expectation you were looking for. We discovered that serotonin, the molecule that we talked about, which is a neurotransmitter, a chemical that communicates signal between two neurons, is also a potent regulator of mitochondria. And mitochondria, the best way to describe it, they are the producers of the energy currency of your cell. Think about it like the power plant in a building that keeps all the electricity going. You need the mitochondria to drive work and provide the energy currency. Serotonin directly regulates the production of mitochondria, and not just the production of mitochondria, the efficiency with which they produce ATP, which is the currency molecule. So that was the discovery, which was purely something we stumbled on serendipitously, but was kind of super exciting. And yeah, that was the work of the whole team that came together that did that.
So now the breakthrough that you've had, you've discovered the exact circuitry in the brain which triggers anxiety, and that the psychedelic molecules that you've been experimenting with, that they have a kind of precision delivery within that circuitry. So are you saying now that you would know where to apply, if there was a precision delivery of a drug, that you can deliver it to only that part of the brain which triggers anxiety? Is that a correct summation?
Okay, so let me just break down what we found, okay? So psychedelics do lots of things. They alter states of reality, they can change your motor movements, they can reduce the degree of despair that individuals feel, they also reduce anxiety symptoms. We have known this for a long time already empirically. We know this clinically now because there are clinical trials on with drugs like psilocybin as well as LSD, MDMA. Ketamine is already out in the clinic as one of the things that is being used. So ketamine is not a serotonergic psychedelic.
Not in India. America and Australia have.
Ketamine is also used in India, and at NIMHANS they definitely do have specific, when there are treatment-resistant cases, ketamine is on the table as a potential available tool to treat it. So we know that these drugs produce these manifold effects. Okay, so simultaneously in response to the same drug, you're getting all these things happening at the same time. But we don't know where they're doing this in the brain and precisely how they're doing this. We have suspected candidates, but we have not really nailed down which circuit exactly does what. So for this particular study, a very talented young graduate student, Prachi Tiwari, who said, I want to figure out the circuit that reduces anxiety. And I was like, this is going to be a task, right? It's going to take us some effort to pull this off. So the best analogy I have for this is, imagine the brain is India, okay? And you know that the drug could be working anywhere in India to give you the effects. You first will look for where the receptors are expressed very highly. These drugs work on the serotonin 2A receptor. They work on other receptors as well, but we think the serotonin 2A receptor is one of the main receptors through which they mediate.
So just to keep the, just so that the audience understands, that the psychedelics,
binds to this receptor.
it binds with
Yeah.
the serotonin,
Yeah,
which impacts your mitochondria.
It binds, no, it binds, yeah, it does affect your mitochondria. It binds to this receptor. So
And then what happens? So
Yeah.
before you tell us more about the breakthrough, why was psychedelics even being looked at as a cure or a,
Actually,
what happens with
yeah,
psychedelics and
I
anxiety?
mean, what people have found is so empirically we knew people reported feeling like their anxiety symptoms were better when they took psychedelics. So that was
because your self dies down.
yeah,
and
you can
your lens changes.
You can self-report and say, I think I feel better, right? So people did report that. And then there have been clinical trials as well where people have shown that there seems to be an effect on generalized anxiety disorder where certainly for post-traumatic stress disorder, these molecules are being considered. So there's reason to suspect they do something. How effectively they do it, whether every psychedelic is the same, is still a matter of discussion, debate, and work. But we do know they work, and we know that they work on rats and mice also to reduce their, now you'll ask me, how the heck do you know if a rat is anxious? Like you can't ask, are you anxious? So how are you even figuring that out? So the way we do this is we use these behaviors called approach avoidance tasks. So anyone who has had a mouse or a rat in their house knows that it's not wandering around in the middle of the room. It's usually clinging to the corners or hiding in little black holes so that it doesn't like to be in the open where there are bright lights, etc. So we have a task in which we're looking at its approach avoidance behavior. It will tend to cling to the periphery, tend to be in dark spaces. But under the influence of a psychedelic, all that just disappears. They don't seem to have any of that worry. They're in the middle, happily exploring.
Jhoom le thoda.
They're very quite happy to be exploring all territory without concern. So that other drugs that treat anxiety also do similar things. So what Prachi wanted to ask was, how do we narrow this down? How do we find which part of the brain actually gives you this effect? So let's say India is the brain. You suspect that the action may be in Delhi where the receptor is. So you might go looking in Delhi. Turns out it's not Delhi. That Delhi is not the place. So even though there's lots of receptor there, if
Delhi is not the place where you lose anxiety, for sure.
Certainly after the last discussion, we can be certain about that. It's probably not the place where anxiety goes away. So no, it was not the prefrontal cortex. It was not the basal amygdala. So we went circuit by circuit looking. And of course, my favorite city will be the analogy I give this with, which is Mumbai. So obviously, that's where my heart lies. So essentially, we found...
You're so not a politician. You would say that anxiety relief happens in Chennai.
That's true. Clearly not. I don't have anything to sell. So the ventral hippocampus was the structure we found where if you deliver the psychedelic straight into this part of the brain, it reduces anxiety, but it does not produce hallucinatory-like effect. So that was already interesting to us. That means that the drug that produces so many things at the same time is doing it through discrete, different parts of the brain. So you can parcelate out now, hey, the effect on anxiety is coming through this circuit, but not the hallucinatory effect. So already you're begin to sort of dissect that out. And then in that circuit, so think about it as, okay, you found it's Mumbai. It's not all of Mumbai, it's Marine Drive. And then on Marine Drive, it's not every neuron in Marine Drive. So it's not every building in Marine Drive. It's just the really nice Art Deco buildings in Marine Drive. So narrowing it down bit by bit, we found that it's a certain class of neurons in the ventral hippocampus that get targeted by the psychedelic. And when you go in and actually just activate these neurons, it's enough to reduce anxiety. And because we can, in rats and mice, we have a lot of powerful chemogenetic tools that allow us to just switch on the firing of neurons and switch off the firing of specific neurons. We can actually ask, hey, let's not even give the animal a psychedelic. If those neurons are that important, we should, in principle, be able to go in, switch on the firing of those neurons, and reduce anxiety just by doing that, which is what we found. So that narrows down the spot in the brain where these drugs work. Why that's important is because in the long run, you may want to be able to separate the effects of these drugs. You don't always want the hallucinatory effect. You may just want the effect on anxiety. And because the way things are, you can now design psychedelic-inspired drugs, batteries of them, I mean, lots and lots, thousands of different chemical combinations. And you could come up with a way to say, I want a psychedelic-inspired drug that doesn't produce the altered perception and the hallucination, which, for example, is a serious risk factor for someone with bipolar disorder or a history of potential risk for psychosis, even a genetic history, and just treat this aspect. So that opens up that possibility. This is one circuit for one behavior. Translating this to a human is still steps away. It still jumps away.
First of all, that deserves a clap, I mean, I'm going to plug a platform that we do right now called Synapse. I would love all of you to block your dates on 22nd and 23rd of February. We do that in Gurgaon, but it's a huge platform. We bring more than 40 cutting-edge speakers, among them Vidita, from across the world. But why I was saying this, and we would love all of you to come, is that the amazing marvel of what science is achieving. I mean, the brain has like 7 billion neurons and 8 trillion synapses. And like you just said, your work has, in all of India, narrowed down to one Art Deco building in Mumbai where stress can be shut off. That's a massive find. But here's the caveat, that this is in rats. So are you saying that there's a similarity, and this is going to shoot us straight back into discussions of consciousness, that is the rat's brain and a human brain anything similar?
Yeah, so I'm going to give you the bad news. We're not that different from our rat and mouse cousins. So, I mean, we'd like to believe that we're very special and that evolution sort of put us on some pinnacle of a ladder. That's absolutely not true. We are some side branch, relatively recent evolutionary attempt, may not even be very successful on evolutionary timescales. Let's see, that's still to be figured out. But no, so biology is parsimonious in nature. If something works, it uses it over and over again. So there's no reason to believe that our nervous system is so drastically different from that of a fruit fly or a rodent, a rat, a mouse, certainly much closer to our non-human primate cousins. But the receptors that the drugs work on are there in a fruit fly brain, they're there in a mouse brain, rat brain, human brain, etc. Right? So the receptors are there. The circuits are not drastically different. We have a wonderful team of colleagues here from IIT Madras who are sitting and doing the anatomy in the human brain and mapping circuits there. But the human brain is certainly larger, more complex. We expanded our prefrontal cortex and our cortical regions in evolution substantially. So there are differences. And what we find in rats and mice, we have to check that this is exactly what happens perhaps first in non-human primates before asking the question in humans. But it's actually now possible with imaging to ask this question in humans also. It's just that you now have some sense of, let's go look in the ventral hippocampus and see if this is something like this is happening, right? I would be surprised if it's drastically different. Rats and mice are themselves mice are not just smaller rats, they're totally different species. So already in these two species, it seems to be exactly the same. So I would say, if I was taking a bet, I would say it's quite likely that that same circuit gets hit in non-human primates and in humans as well.
So two questions to that. One is that what is then stopping a human trial? Because this seems a gigantic breakthrough. What's the difficulty then of precision? Because like we had Robert Langer at Synapse, and we know that super precision delivery of drugs is happening. So what makes it difficult to do it in the human brain? And secondly, is this then demystifying psychedelics altogether? Like, then you don't really need your ego self to die. You don't need this hallucinatory or the other superior dimension. It's just then another medical drug, like it's just one chemical. We've demystified psychedelics.
Let me answer the first one first. Okay, so the challenge is the following. In the rats and the mice, first of all, we can deliver the drug directly into the ventral hippocampus. It's a little unlikely that in humans, we would be able to do direct delivery of the drug locally into just that part of the brain, partly because it's surgically being delivered. So the idea of using that sort of a major intervention, which is sort of so invasive, is unlikely to be the path we will go down the road for anxiety and depression. The second part is, okay, let's say you know that it's these Art Deco buildings you want to hit, the parvalbumin neurons, these parvalbumin positive inhibitory interneurons, that's what you want to hit. It presumes that the only Art Deco buildings exist only on Marine Drive. right? That's the equivalent of that, which is we have tools in the mice to go and only manipulate those buildings or those neurons, but parvalbumin neurons are in the cortex, they're in the striatum, they're in multiple other parts of the brain. So why, when you give the drug to the human being, would it not work on those neurons in many other places? Clearly it does. Because we can narrow it down to this degree and extent in rodents using lots of tools that we currently cannot even possibly apply in humans, it's hard to make the straight out leap that we can go in and just activate those neurons. But what we can do is start running this on batteries of drugs that are being currently synthesized. And there are lots of people around the world who are using the backbone of the psychedelic, knowing the structure of these molecules and saying, I'm going to move this branch there, I'm going to do this. So you can just modulate those drugs and generate batteries and batteries. When you do that, you might find drugs that are more selective in the way they hit the receptor or localize the action. So that's promising. It's likely that that will be a path that people will go down. There's certainly already several people doing that. So that's the first part. The second part, I'll say the jury is out. I would not want to, this is the big question that people have who are interested in the therapeutic effects of psychedelics, which is the acute subjective experience of taking the drug, which gives you these altered sense of perception and reality, extremely important for the therapeutic effects? Do you need to experience that to actually have the therapeutic effect? All the data in rodents points to the fact that the circuits are separate and there are many different circuits that it's working on. It still doesn't mean that in humans that experience is not a vital experience, that the sense of ego dissolution or a reduction ruminative thought is not important. I would not rule that out at all. I think what it just does is research on psychedelics stagnated for so long because of all the bans, right? Which prevented not just, access to people, but absolutely prevented work from happening. That has changed in the last 10 years. So I think you'll have an answer to this down the road. I would still say the jury's out. Our work points to the possibility that it could be separatable, but I will not make that claim at the moment at all. I would be cautious before making that particular claim. I think India, for example, needs a progressive policy on how we are going to approach psychedelics in the context of mental health therapy and mental health treatments. We don't have one at all at the moment. We don't know what we're going to do. We don't even discuss this actively. We need to know how we will inform ourselves, because otherwise, with treatment resistance and patients seeking some form of relief, they will access it in ways that could be potentially dangerous. These are very potent molecules and certainly not something to be played with lightly. We need a regulatory structure. We need our own clinical trials that have an Indian context so that we understand what we want to do in our own progressive and appropriate policies for this. We're far behind on that, and we really need to have this as an actual topic of discussion, because India will have a burgeoning mental health crisis. There's no question about it. It's already there. It's only going to get worse.
So just a final question, I'm not going to take you down consciousness. I just realized it's 9:20. But it's fascinating because the psychedelics really make you understand what is human consciousness, opens up many questions and doors into spiritual experiences, transcendent experiences, the nature of the brain, nature of consciousness. But given that America and Australia have opened it up, without the precision application, as you just, the breakthrough you all have had, just when you apply psychedelics to those who are depressed or who take it as therapy, what exactly happens? Does that effect remain when they lose their ego self and they see the world in different light? Does it permanently alter that lens and take you somewhere, turn you into a new person? Or does the effect die like a Disprin?
No, I think the effect dies because there's a period of time for which the drug is on board and it goes away. What seems to be working is psychedelic-assisted therapy, which is what people are imagining this as a state in which it allows you to access perhaps trauma memories, perhaps things that need to be reoriented in the nervous system in terms of one's view of them, under the influence of the psychedelics. I think the jury's still out on exactly what will be the most effective utilization of these drugs or drugs that come down the road in terms of, but I think we're in a good space now because we're at least asking these questions, right? You need good clinical trials, you need sensible policies, you need the science before you open it out in a laissez-faire manner, which could be potentially deeply problematic. I think if you do that and you do that well for a period of time, you have a much more informed understanding of what these molecules will allow you to do. And I think people are going to access them whether you officially do it or not, people will access it. That's, I think, a scarier place to be because you don't know other impurities, you don't know what the drugs are, you don't know the conditions in which, so that's a scarier space. I think if you have a progressive and sensible policy, you can actually find effective utilization, the most appropriate utilization.
So just two last things. You were sharing with me earlier that this is an area where your memory of emotions and how you process emotions is this same area in the brain.
Yes.
And so if you're feeling suicidal, or that it could actually really flip you out of that. And the way you process memory, emotions, life experiences could really, this is the region
yes,
where
so the
it
ventral
happens.
hippocampus is highly important for emotional salience. So the best way for me to describe it is to ask this audience, where were you on 26/11, which is, I guess, our equivalent of 9/11, and most of you who would remember what you were doing on either of those dates. But if I ask you what were you doing the day before and where you were, or the day after, you won't. So why do we have such strong recall of days where there is heightened emotion or heightened response? It's because our brain cares about those moments and remembers those. We weed out lots of non-relevant, irrelevant information. The brain just gets rid of it. Emotional memories are regulated and controlled by the ventral hippocampus, which provides this ability to remember emotionally rich memories. So yes, it's the same part of the brain where the psychedelic is targeting cells.
So that's, as I said, a massive breakthrough. Rat or not, we all know that there is a continuum between rats and us, metaphorically as well. So it's amazing that you've done this. Absolute final question is that you've said that ancient cultures have used this, and we are in a way making a modern return to these ancient cultures. What is the sort of distinctive thing that ancient cultures did, which in the modern world we are not doing in relation to psychedelics?
I think the single word that distinguishes the way we look at molecules and the way ancient cultures did is with reverence. I think our reverence for plant-derived substances that have a profound effect on you as an individual, we view these as molecules that perhaps do not evoke a reverence in us. Most of these molecules have come from cultures where they were part of ceremonies that were highly reverential. And so that, I think, is very interesting, because I think associated with that comes with it a respect for the power of the molecule and what it can do to your brain. I think as a civilizational time right now, we are laissez-faire about what we will put into our nervous system, with very little reverence for the potency of many molecules and what they do to the brain, right? So I think that's the single biggest difference, that we are not reverential towards the power of molecules like this. Yeah.
Thank you very much, Vidita. Thank you for that work. And to the team here. Our big effort really is to make science and technology as exciting as politics and religion, because truly it's the new hand of God reshaping our world and our understanding of ourselves in every possible way. And it's scientists like Vidita that are, it's just marvelous. So thank you very much for sharing that with us. Thank you, everybody, and see you next month. Thank you for being here.